Good evening, ladies and gentlemen. Thank you very much for giving me a voice. Today I will talk about cassava, which is cassava utilization into hydrogen production by work published in Biochemical Engineering Journal by Dias Lopez from West Paraná University in Brazil. As I said, cassava is one of the most common waste, which contains up to 30% is skin or stem waste that need to be utilized. In case of comparison with, for example, pineapple, it gives that pineapple was better. But here we see that we can have production only of cassava using the different hydrolysis. And there it was as African. However, cassava and pineapple cassava is very important in the case of Brazil economy. Not only so important in Nigeria and surrounding, so Middle East, but also of using. The work is based on documentation, while is processed. Here we have a column from 100 for 5 hours in case of African work by Professor Sergio Casella and Diego Cagner. In case of work of only for cassava, we have higher reactor because 1.7 against 120 milliliters in case of African cassava and pineapple. Here we have also the shaking, keeping in 35, not like in case cassava, in case it was 40, so upper. Here it is middle temperature. And other case, as that we use the substrate is besides the cassava way, also some synthetic based solution with urea and iron salts and nickels. Why they added? Because iron is the base of occurring of enzymes of hydrogenase. Other is nickel. So nickel salts and iron salts are going to increasing activity of hydrogenase enzyme that transfer the glucose by pyruvic acid to hydrogen. During this pyruvate butyrate is occurring to process into acetic and acetic acid no more. So no more than 33%. Therefore we have this hydrogen production. And this is the reason. And here we have in case of 1,7 the mixing on 300 while In the case of we have little and without, the pulp was only hammer mill and no other hydrolysis, no other preparing of cassava. In the case of work by Brazil, there is a substrate preparation was effluent treat wastewater, so through a treatment by structure industry, so part of its way. There is was containing wasn't processed, was only treated thermally by 95 degrees for 15 minutes to 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 reduce methanogenic bacteria. Similarly, because we don't have inoculum specially, because here in cassava was taken from anaerobic digestion by chicken manure. And this is the difference. This is self-produced. pH was, in case of cassava, only cassava in Brazil was changed. It was variable. We have 4 samples to discern which conditions are better, from pH of 4.3 to 0.1, 0.3, and 0.7. There is why this cassava is produced. And we have 4 samples. Cycle number is so was for 3 months, while in case of was 28 days. In case so was longer the time of experiment. So we have the quite good because it's more using more surface, and in case we have initial of 5 gram per liter of initial substrate, and in case of in Brazil we have 2000 milligrams per liter, so much longer. So it's more useful because more as waste, typical waste. We get the similar suppose. So how it works? So the tetraethyl lignin was containing from 28 to 20%, and cellulose 62 and 90%. While in case of where if cassava, the lignin content and substrate conditions was 86 was lignin, 18 cassava was hemicellulose was 722. So the transmitted while lignin when the cellulose was 43, and here lignin was only 28. So much more pretreated was this case in case the skin and case of African than here. Therefore, some differences will be in result. The hydrogen production in mostly in case of 5.1 was the highest, and case of 4.3 was even higher, that coined 5.7. So best pH was between 5.3 and 5.5. 5.1 and 5.3. The 4.7, 4.3 was higher than that. And this is showing that fraction in metabolites was in case of pH 0.5, 4.7 was in case of it was the lowest fraction of acetic and butyric, while the highest hydrogen production fraction by percent was for pH 5.7. So we see that difference in percentage, maybe it's not volumetrically, but in percentage was much more from that other cases. They use conditions, so we have that highest production was in 5.1 was 0.8 liter hydrogen per liter of amounts. One case of cassava in case of work was 62 per gram of substrate. So this is 2 times lower, but it's strange. So more for hydrogen production was 1.4 more kilogram for hydrogen yield per kilogram of carbon. So was 1.8 was according to work was more than in case of the work which is not used, because it's less fraction, less hydrolyzed in case of work of triangle that in case of work of Brazil. So for cassava tree, cassava had what it starts. The better was used proposed by hydrolysis and wastewater than skin, but both methods should be mixed because propose different possibilities and mixture could be the of these two research should be the optimal. Thank you very much for listening me.